These are the Advanced Math Notes 2.3. Objective 2.3, title, solve equations. Solve. Number 1, x to the fourth minus 9x squared plus 20 equals 0. All right, it's already equal to 0. It looks like it's ready to go. We go straight to factor and solve. And the only difference is, and we've seen these in this class already, is instead of x and x, because x times x is x squared, I want it to be x to the fourth, so I have to add powers of 2 in here. So that x squared times x squared is indeed x to the fourth. All right, this tells me the two signs are the same. This one, the neighbor tells me that they are both negative. And what are we going to use? It looks like 5 and 4. Negative 5x squared, negative 4x squared adds up to negative 9x squared. Negative 5 times negative 4 is 20, and x squared times x squared is indeed x to the fourth. All right, a quick side note. Back when there were no squares on there, when you first learned factoring, it was something like this: x squared plus 5x plus 6 equals 0. Now, we didn't do a whole lot of talking. I mean, we did discuss that this was a trinomial guess and check, and it had to be in this form. But if you look at the powers, half of 2 is 1. Half of 4 is 2. That pattern will always work out that way. Again, that power's 2, that power's 1. Do not know why it's so fuzzy. I'm hoping it's not showing up fuzzy on your end. Half of 2 is 1, half of 4 is 2. We want to look for that pattern because they're going to end up a little more complicated eventually. All right, so let's continue. X squared equals 5, x squared equals 4, and we get that once we set them both equal to 0 and solve. And then we square root both sides. X equals, the square root of 4 is 2, but we do plus or minus when we square root both sides. 5 is not a perfect squared, so x equals plus or minus root 5. And those of you that are wondering, well, couldn't I have still factored? Yes, you could have. X squared minus 5 doesn't factor. It's not a difference of 2 squares. But that one is x plus 2, x minus 2 equals 0. You'd still end up with positive 2, negative 2. That's the plus or minus 2. And then when you square root both sides, you get plus or minus root 5. So either way, in the end, we end up with the same set of answers. Plus or minus 5, comma, plus or minus 2. Okay, number 2. X to the fourth minus 4x squared equals 21. We can see where it looks similar to number 1, but number 1 is equal to 0, and it has to be equal to 0 in order to work these out, to use the zero product property. So we're going to subtract it over this way, and the reason I subtract to the left is because I want my leading coefficient to be positive. X to the fourth minus 4x squared minus 21 equals 0. And as we stated before, look at the pattern. Half of 2 is 1, half of 4 is 2. So it's the proper form, it's in the proper setup method for us to use the trinomial guess and check. And we can tell it's going to be x squared and x squared because that is the only way to get x to the fourth with these type of problems. And we want it to be x squared in the middle. Another way to think about it, when we factor to these, This here, these powers were always 1 because x times x is x squared. You could also look at it as it is the middle power, either way you think of it. It's 2 and 2 here because x squared and x squared is x to the 4th. Or you can think of it as it is that middle power. Again, you may be thinking, why in the heck is she explaining this? We know this already. We're going to get to fractional exponents in the next problem, so you want to make sure you recognize these patterns. X squared and x squared, you can think of it as the middle, or half of 4 is 2 and 2. Half of 4, 2, 2, or use the middle power. All right, I know it's going to be plus minus because negative 21, the only way to get a negative is if one is positive and one is negative. Plus 3 minus 7 to give me the negative 4 in the middle. X squared plus 3 equals 0. I'm going to move over this way. X squared plus 3 equals 0. And x squared minus 7 equals 0. X squared equals negative 3. X squared equals positive 7 once you move them over to the other side. Square root both sides. And I know to do this because here is not factorable. This definitely is not difference of two squares because of that plus sign. And this has a minus sign, but 7 is not a perfect squared. All right, I'm going to do this one first. X equals plus or minus root 7 because 7 is not a perfect squared and nothing breaks down. Here, can you take the square root of a negative? I'm hoping you're saying no. This piece here has no real solution. All right, no real solution because the square root of no number is going to equal negative 3. The square root of 9 is positive 3. The square root of negative 9 does not equal negative 3. All right, so no real solution on that one. So your only solution is the plus or minus root 7. Again, because you cannot take the square root of a negative and get a real solution. All right, number 3. Here's where it gets a little harder. These are the ones you're going to see on the test. X minus 2 to the 1/2 plus 3 parentheses x minus 2 to the 1/4 minus 10 equals 0. Okay, can you see that there's 3 terms? Can you see that this is x minus 2 and x minus 2? The powers are not the way we're used to, but they're still powers. Recognize first that this is a u substitution or w substitution problem. I'm going to let w equal x minus 2. So this gives me x to the 1/2 power, and I should not be using x, w to the 1/2 power, w because we let w represent the x minus 2, plus 3w to the 1/4 power minus 10 equals 0. Okay, so remember what we said about patterns earlier. Half of 2 is 1. What is half of a half? Take a half, cut in half, and you do indeed get 1/4. So this is in the proper format for us to do this guess and check, the trinomial guess and check that we've been doing. And it's not only the right format, but it's in the right order. 1/2 power, 1/4 power, and a constant. Half of a half is a 4th. All right, so we double bubble. And we know it's going to be w and w. And I told you there were 2 ways earlier. Either take a half of a half of a half is a 4th. 1/4 plus 1/4 is a half when we multiply through. Or just simply look at your middle exponent and say, oh, that's 1/4, that's what I'm going to use. Your choice, up to you. I know the signs are different because of that negative 10. And I'm going to do plus 5 and minus 2. And I get positive 5 and negative 2, and that gives me the positive 3 in the middle. All right, I'm going to do 2 things at one time. I'm going to set these each equal to 0 as well as plugging the w back in. So parentheses 1/4 plus 5 equals 0. Parentheses 1/4 minus 2 equals 0. So I'm taking each one of these parentheses, setting them equal to 0, and putting the w back in. And the w is the x minus 2. Now, when we've done substitution in the past with these problems, we would simplify at this point. We distribute and combine like terms. Well, I can't do that because of the 1/4 power. There are no like terms. I cannot combine like terms here. So I'm forced to subtract 5 over to the other side. Gone. X minus 2 to the 1/4 power equals -5. I'm going to pause here, do the same thing over here. I'm going to add the 2 over. X minus 2 to the 1/4 power equals +2. I'm going to do this one first. What do you raise both sides to get rid of that 1/4? I'm sure you did this last year. You definitely did it in Math 2. You raise both sides to a certain power to get rid of the 1/4. You raise it to the reciprocal power. You raise it to the 4th power. I know that's getting a little scrunchy in there, a little crowded. I raise both sides to the 4th power. 4th power is equivalent to 4 over 1. Why do I do that? Because a power to a power you multiply. And what's 1/4 times 4 over 1? It is simply x minus 2 equals 2 to the 4th is 2 times 2 times 2 times 2, which is 16. And then you add your 2 over and you get x equals 18. I'm going to just do a quick check right here just because it's going to help us in the long run. I'm going to check it right. I'm going to check it, excuse me, right here before all those scribble marks. Okay. 18 minus 2 is 16. 16 to the 1/4 power is the same as the 4th root. The 4th root of 16 is 2, and 2 equals 2. Do you see that? 18 minus 2 is 16. The 4th root of 16, that means 4th root. The 4th root of 16 is 2, and 2 equals 2. All right, next one. Same thing. What are we going to raise both sides to? 4th power. One over 4 and 4 over 1 reduce, leaving us with x minus 2. -5 times -5 is -5 times -5 is positive 625. Add the 2. X equals 627. All right, I do want to do a quick check right here. 627 minus 2 is 625. 625 to the 1/4 power is the same as saying the 4th root. 625 to the 4th root of 625 is 5, not -5. Okay, so now we have a problem. This actually is no solution. Okay, I am going to explain one more time why. You can think of, okay, choices when you're doing these problems. Do all this work. When you get down to your answers, kind of check in here to see if they work. One way to avoid that is if you remember right here, I'm taking the 4th root and I'm asking, this question is asking the 4th root, again 1/4 power means the 4th root. The 4th root of what number is -5? Can you see that the 4th root of no number is ever going to be negative? It's like asking the square root. It's like asking the square root of what number is -5. That's never going to happen. Well, you can square both sides to solve it and say x equals positive 25. But when you plug it in, the square root of 25 is not negative 5. So when you're taking the square root and you're asking yourself the square root of what equals a negative, it's not going to work. The same is true for the fourth root, any negative number. The fourth root of what number is negative 16? It's not going to happen. Okay, so what two things have to happen together for there to be no real solution? The two things that are going on together is, I know this is getting really messy, this denominator is even. So a 1/2, a 1/4, a 1/6, a 1/8. If that denominator is even, like right here, the square root would be a 1/2 power. And this number is negative. If those two things happen at the same time, that section is going to have no real solution. X equals 18 is still a solution, but the left side had no real solution. Again, what two things happened? Fourth root, which is even, and a negative. This one worked over here. There was a fourth root, but 2 was positive, so it did work. If this had been a third root or fifth root, those could be negative, because you can take the cube root or fifth root of a negative and get a negative answer. I definitely will talk more about this as we go, because that was kind of a lot and confusing to take in one problem. All right, so the only answer for number 3 is 18. All right, I'm going to move on. Number 4, 6, x plus 1 raised to the 2/3 minus x plus 1 raised to the 1/3 minus 1 equals 0. Okay, first I'm hoping you're recognizing that it is W substitution. 6W to the 2/3 minus W to the 1/3. Take away 1 equals 0. Do you see what I've done? I replaced all the x plus 1s with W's. Let's check if it's the right format. What is half of 2/3? Half of 2/3 reduces to 1/3, which is the middle power, so we're good. So we're going to double bubble, equals 0. And for the 6, you can use 1 and 6 or 2 and 3. Go ahead and try to factor. Hit pause if you'd like. 2W, 3W, minus 1 plus 1, negative 3, positive 2 is going to give me the negative 1. And I am missing a piece. I'm hoping everyone can see. Wait a minute, she needs her exponents. Two ways of thinking about it. Either simply take the middle power or cut the first power in half. Half of 2/3, we did it over here, is 1/3. Make sense? All right, we plug our W's back in. I'm going to plug it in and set it equal to 0 at the same time. 2 blank, 1/3 minus 1 equals 0. 3 blank, power 1/3 plus 1 equals 0. And I'm going to plug this W here back in. X plus 1, X plus 1. And I'm hoping everyone recognizes and remembers from last year, that yes, I can move the 1 over. I'm going to do that first. I'm going to add 1 to the other side. 2 parentheses, x plus 1 raised to the 1/3 equals positive 1. What I cannot, absolutely am not allowed to do is distribute this 2. If you were tempted to, or if you did it already, pause and rewind. Not allowed to distribute that exponent. Why? Because the power of 1/3 there, if that was a squared or a cube, same thing. I could not distribute. If that power was not there, and it looked like this, then we can distribute the 2 and be good. Distribute the 2 and solve. Once you throw any kind of exponent there other than 1, you are no longer allowed to distribute. But you are allowed to divide out over to the other side. And that leaves me with x plus 1 raised to the 1/3 equals 1/2. And just like the page before, I'm going to flip it over really quick. I know it got messy down here, but do you see where I raised both sides to the reciprocal power? Sorry, out of screen. I raised both sides to the reciprocal power. I'm going to do the same thing here. So what would I raise both sides to? To the 3rd power, because 3/1 reduces to the 1/3 width, and I'm left with x plus 1 equals 1/2 times 1/2 times 1/2 is 1/8. And I'm simply going to subtract 1 from both sides, and I'm hoping everyone can recognize that subtracting 1 is the same as subtracting 8/8. Why would I write it as 8/8? Because I want them to have a common denominator. 1 is the same as 8/8. That reduces or cancels out. X equals 1/8, take away 8/8 is negative 7/8. All right, next one, same concept. I'm going to this time subtract the 1. 3 parentheses x plus 1 raised to the 1/3 equals negative 1. And I cannot distribute that 3, but I can divide it over to the other side. 3 is gone. X plus 1 raised to the 1/3 equals negative 1/3. And then we raise both sides to the reciprocal power. The reciprocal power being 3, or 3/1, so that it'll reduce with the 1/3 power. X plus 1, sorry about that, Val. X plus 1 equals, and the negative 1/3 times negative 1/3 times negative 1/3 is negative 1/27. I want to pause here because I will often have kids stop and say, wait, Mrs. Torres, you said on the page before that it can't equal a negative, so this is no solution. That is correct. It cannot equal a negative when this denominator is even. 3 is not even, so we can work with the negative number here if that number is like 3 or 5 or 7 or any odd number. All right, so we can continue. We're going to subtract 1 from both sides, but remember subtracting 1 is the same as subtracting 27/27. And why do I do that? Because 27/27 is the same as 1, and I want them to have a common denominator. X equals negative 28/27. So x equals negative 7/8, comma, negative 28/27. Okay. Make sure you're getting questions ready to ask me tomorrow in class if you have any. Next one, number 5, 6x to the negative 2/3 plus 7x to the negative 1/3 minus 3 equals 0. Now, how is this different from the others? They have negative exponents, but we know how to deal with those. We know how to change them. Remembering here, the 6 stays at the top. The x to the 2/3 moves. 7/x to the 1/3 minus 3/1 equals 0. Common denominator is x to the larger power. 2/3 is larger than 1/3, so it's x to the 2/3 that we're going to multiply everything by. For example, if these denominators were x and x squared, you would choose x squared as your common denominator. It's always your larger exponent. Okay, this is going to reduce completely, leaving me with 6 plus this one. Remember, when you reduce, you subtract exponents. So 7x raised to the, what's 2/3 take away 1/3? When you're reducing and they're like bases, you subtract the exponents. 2/3 take away 1/3 is 1/3. Minus nothing reduces. 3x to the 2/3 equals 0. Now it's backwards, and I don't like it backwards, and I only leave it backwards if I have to, but since it's an equal sign, I can divide both sides by -1, and I talked to you guys about that in class yesterday, or earlier today, or we can move everything over to the other side, your choice. I'm going to divide positive 3x to the 2/3, take away 7x to the positive 1/3, and then minus 6. Out to the front positive, in the middle negative, out at the end negative, equals 0. Let's check if it's in the right format. Half of 2/3 is 1/3, so we're in the right form. Double bubble equals 0. I know it's going to be 3x and x. And remember, I keep telling you guys, how you choose your power is up to you. You either look here and take the middle exponent, or you take half of your first exponent. Either way, you're going to get 1/3 and 1/3. I know it's going to be plus and minus because the only way to get to a -6 is if one is positive and one is negative. Try it on your own. I know if I'm going to try 2, 3 and first, it may not work, but I'm not going to put the 3 here. So I'm going to put 2, 3, and see if my signs are correct. If not, I will fix them. Positive 2, -9, -9 and positive 2 is indeed -7. If you ended up with positive 7, you just flip your signs and be good. All right, I am going to solve in our heads. X to the 1/3 equals, subtract and divide, -2/3. X to the 1/3 equals positive 3. And I'm running out of room, so I'm just going to squeeze that over here. X to the 1/3 equals -2/3, and x to the 1/3 equals 3. All right, so remember, this cannot be negative when that denominator is even. 3 is not even, so we can take the cube root of a number, a negative number, and get a negative answer. So we raise both sides to the reciprocal power. What's the reciprocal of 1/3? 3/1. And I'm just going to write that as 3. 3/1 is equivalent to 3. That reduces. X equals, when you're cubing, because you're just cubing a fraction, you can cube the top, cube the bottom. What's -2 times -2 times -2? -8. What's 3 times 3 times 3? 27. Or you can think of it as -2/3 times -2/3 times -2/3, which indeed is -8/27. So remember, you can end up with negatives here when the denominator is 3 or 5 or 7 when it's an odd number. All right, next one, we're going to do the same thing. Raise both sides to the 3rd power. Cross out there. X equals 3 times 3 times 3 is 27. So -8/27, comma, positive 27. Okay, I know these notes took a little longer than usual, but there was a lot to cover that I want to make sure you understand. Be prepared, be ready to come in with questions tomorrow and get them all cleared up.